Yeah, so my name is Tomas. I work for Outreach as a software engineer. And today I would like to briefly tell you the story about GraphQL in Outreach. So it all started in January 2019. Back then we had only our REST API, and our front-end developers decided that they need a GraphQL layer, and they just created this wrapper around REST API, which was basically taking JSON schema of the REST API and auto-generating the basic CRUD operations in GraphQL. So that was really fast and great way how to introduce the whole schema at once, so they can use it on the client. So there was this timeline that it took a while until it got into production. Actually, it was around 1 year. And then in 2021, the decomposition started of our old flagship of our REST API. So that brings some problems to this architecture, actually, because before it was just auto-generated, so not so many developers were actually touching this layer. So with this decomposition, you can see that we choose gRPC communication between our GraphQL gateway and the new microservices decomposed. So with this, there was not real ownership. So at start, front-end developers were used to go to this layer and just adjust it as backend for front-end. But with this new approach, there was need for backend developers also to touch it from time to time. So they were confused who should really do this work, because it's on the backend, but it was developed by frontend. So no one really knows who will do the job. Then there is a problem with overfetching via gRPC. So in GraphQL, you are able just to pick whatever you need from the type, and in gRPC you are not able, at least in default implementation. So you would just fetch everything from your database, send it over gRPC, and you will just throw it away in GraphQL, which is not really great. Then there is problem with types and its duplications. So you can imagine that you need to define this gRPC struct. We are using, for example, Golang. So we were developing in this microservice level and creating struct, for example, user. And then you need to generate a gRPC client for our NodeJS GraphQL gateway. And you need to transform this generated client types to GraphQL, actually. So a lot of work on multiple places. Then there is obviously this monolithic approach. So many developers were developing in this layer from this time. So there is thousands of lines of code, and one team is only responsible for the quality and infrastructure. So it was really problematic to maintain actually this code. And we have some performance and memory leaks. For example, we had this memory leak with our gRPC clients. So it was there actually from the first day, so for many years, but it started to pop up after we started to decompose more and more services. So actually the problem was that we were creating a gRPC client for each request, and it was not closed properly. So with each request, you had this small memory leak. So Fix was just about to create one gRPC client at the start of the application and reuse it for every request. But yeah, it was hidden there from very beginning, and it was quite difficult to find. Then obviously it's Node.js as a tier 0 service. So as I said, we are decomposing everything into Golang. So it really doesn't make sense to have one Node.js service as a tier 0 service which will handle all the requests, right? With you have more performant Golang as a microservice, and then you are slowing everything down in this layer. And then our backend developers are used to write everything in Go, and it's quite annoying for them to switch context and write something in TypeScript. And some of them really don't like TypeScript at all. And the same thing is with our front-end engineers. They are used to write code in the browser, a single thread, and now you have a service which is in distributed world. So it's quite dangerous to play with it. So these are the problems, and now what we could do to solve them. So this is how it was working from the very beginning. So we had GraphQL resolvers and even SDL schema of GraphQL inside the gateway. And so the problem is that microservices basically don't know about the GraphQL at all. So yeah, that was problematic. So first thing that we could do would be to use something like GraphQL schema stitching, which is actually moving the SDL part and the resolvers itself into microservices, which is great because we would move a lot of code from the gateway. But still, there is a need for developers to touch this GraphQL gateway because it's an imperative way how to stitch schemas. So you need to define in the gateway what is extending what, basically. So, but yeah, quite an improvement. Then there is something called Apollo Federation. So that solves, again, the movement of SDL and GraphQL resolvers into microservices. And one big advantage of this is that it's using a declarative way how to connect microservices. So services are basically aware of each other, and you can extend types from different services. The only disadvantage is that it's a little bit more complex because we need something called schema registry right now, just to register all the SDLs with each change in microservice. So yeah, we went with this way because, like, even though it's a little bit more complicated, it was like best for us because main goal was to remove all the code from this gateway and like force developers out of this layer. So we started in November 2021 with the POC of Federation on our hackathon. Then we continued with design docs and discussions about these docs. And we found out that we need to do a few necessary steps to be able to pass it over to developers. So first was just to create schema registry or use some already working solution. So there was something from Apollo, for example. Then there were some open source solutions also, but it was really the fastest way to just use working solution and service as a platform from Apollo. So we just using schema registry from Apollo at the moment. The second step was actually create federated gateway, which would replace our previous GraphQL gateway in NodeJS. Again, we had multiple solutions for that. There was already created Apollo server in Node.js, and it was like battle tested. It was already used for years in production for different companies. But at that time, also, Apollo came up with something called router, which is a federated gateway, but this time written in Rust. And it was really interesting because it was really thin layer, and it seems very performant from the graphs that Apollo provided. So we took a risk and went with this way. Another step was to transfer or migrate our old GraphQL gateway in Node.js to become a subgraph. So we just put our new router as a tier 0 service, and our old gateway was first subservice, and in Apollo it's called subgraph, which would handle all the requests. So we just added one more hop into our infrastructure, but now we are able to decompose this old gateway gradually, basically. So we needed to support our developers. So we developed something called stencil module. Stencil is basically a code generator templating system, which is developed by Outreach. So if you are interested in code generation, it can be used even for other languages than Golang. So you can find it on the address below. So what this stencil module does is that it will create template with Kubernetes deployments. So you just need to basically add 2 lines of code into your service definition and run the code generator. And it will generate everything you need for deployment for Kubernetes. And then you also have schema change push job, which is one of the important steps that you need to do in federation. So that is basically with each change in your SDL, you will just send this information to your schema registry, so it's aware. Then you need to have GitHub pipelines to check schema changes actually. So with every pull request, you need to check if your changes are composable with other services, and also if you are not doing any breaking changes, and you check it with usage of your clients basically. So if you are removing some field or query which is used by clients, this check will tell you that you shouldn't really do that. Then last step was create some basic dashboards and tracing support, and most importantly documentation. That was very important because as described before, our backend developers were not really aware of our GraphQL layer. They were using gRPC until now, or REST API. So it was very important to create some good documentation, and so they are able to onboard easily. So we started actually in November 2022, and in February 2023 we had basically everything ready. 100% of traffic was going through this new GraphQL gateway, and it was just hitting our old gateway. So this was just a start for everything. And as of today, we have 13 registered subgraphs. So we are slowly going and migrating everything. But it was not really smooth. Like, it might have took us a little bit less time, but there was this problem with, say, performance. Because Apple claimed that this router should at around 1 to 3 milliseconds of overhead per request. But we found out that in some cases, it took even, 30 milliseconds, 100 milliseconds, and even seconds. So it was really strange, and we were in touch with Apollo engineers, and via Wireshark and looking for networks, TCP packets. We found out that it's actually dividing requests into packets for header and for body, and body will arrive late in some cases. So that was really strange, but in this way we were able to find out that it cannot be Apollo router basically, because it was happening in the layers before. So the next step was to check our Kubernetes. At that time, we had quite old Kubernetes versions, so we thought that it might be something, some old bug which is not fixed. But the only thing that we were able to find was that we were using node port instead of cluster IP that would add multiple hops between load balancer and our router. So we fixed that, but still, issue was there. So the next thing it could be was actually AWS load balancer, which might be the most stable service at all. So that would be really strange, but still, we were in touch with support engineers from AWS, and they even upgraded some settings for us because they could see that issue as well, but still didn't help. So after all, the last thing that it could be, it was some client. So we actually found out that our front-end application is sending multiple requests, let's say 10 different requests around the same time. And some of the queries are also very big. I'm not sure if it's quite visible, but you can see that there is length and it's in bytes. So it's around 16 or 20 kilobytes, which is quite big for one request. So we found out actually that when you send multiple requests, and it is divided to header and then multiple bodies, for example. It's for some reason, sometimes it happened that it will arrive to the server, the first packet, then it will send other request packets, and then it will send the body. So that was the issue after all. So we were just trying to optimize our calling of the GraphQL, so not sending so many queries. And actually we turned on also automated persisted queries, which will just send a hash instead of the whole query, so it will decrease the size. So yeah, that after all helped a lot. So we found out that this issue was there for a long time. It wasn't because of this new layer, but yeah, at least we debugged everything. So now we have everything in production, and there is just an example of performance of this new router. It's quite obvious because it's in Rust, and it's not really fair to compare it to Node.js, I know, but yeah, still, like, we need 3 times less memory and 10 times less CPU, basically. So with this, we had everything ready for developers, basically. There were only 2 issues that we had with the federation and its tooling. So one of them was override directive. So in federation, if you are migrating, for example, query from your old gateway to new microservice, you can use a directive called override, which will switch traffic to your new service. That's pretty cool, but problem is that you cannot switch it gradually. So you cannot say, for example, that I want only 1% of traffic be sent to new service, to testing out, and so on. And we were not able to even set up something like that. We want to just test it on one organization in production. So that's something that is Apollo still working on. So we had to write our own native Rust plugin, which is basically using launch darkly feature flags. So we are just using override as a default. So everything should go to the new service. But if the feature flag is off, we will just send the same query back to the old gateway. So in this way, we are able to do it. It's not really a great solution, but it's at least it's working the way we need at the moment. And the last problem, which is much smaller one, was with local development and schema composition. So Apollo has this great tool called Rower. And if you call it with def, it will spin up your microservice, basically. So if you use multiple terminals and spin up multiple graphs, it will put it together, basically as would router do in your staging, for example. The only problem is that in this case, you need to download all the repositories. So if, for example, you have, as we do have at the moment, you have 13 different services, you need to open 13 different terminals and run this command. So we solve it in our dev environment, which is actually running small cluster inside Docker. And it's basically checking each service registered in schema registry. And if it's inside Docker, it will just download current SDL. And if it's not inside Docker, it means that it's not deployed, and it will just take the SDL from the schema registry. And in this case, you can put together the whole schema and be able to develop locally. So that was all the problems. And now we are just concentrating to migrate all the resolvers, and hopefully one day we will be able to deprecate our old gateway. And yeah, that's it. Thank you. Do you have any questions?
Yeah. Can I just? Sure. Thank you. So the registry, the component you introduced in the middle, is that something that's like runtime dependency for the microservices? As in, they start up, they need to talk to registry at that moment, or is it like compile them or build?
No, it's running as a service. Yeah. So we just call it via. Yeah.
Yes. So when the service is actually starting up, it needs to talk to the.
Yeah. Yeah. It needs to actually, if you are running this, we have it set it up, for example, as the post-deployment job in Kubernetes. So once it's deployed, it will just run and it will just send the changes to this registry. And it's important also when you starting your router. So it will download again the whole super schema registry from the schema registry. And it, oh yeah, sorry. And it will also reload if you make any changes in one of your microservices. It will also like do the change into the schema registry, and router will poll for the changes, and it will reload without need for restart actually.
So all the services will be de-updated?
Not all of them, because they don't need it. Only schema registry will get update, and router. Router is important because the router is putting everything together and it's serving as a gateway.
How much can front-end developers participate on the GraphQL schema design?
Yeah, that's a great question. Yeah, that's something that we are currently dealing with. We came up with something like working group. So we are trying to force front-end developers to cooperate with back-end developers, because they were like used to just work on their own. And in idle situation, front-end developers should come up with the schema change, for example, and there should be discussion with the back-end developers if it's really feasible and if it will be performant and so on. But yeah, we are still like very early in this process, so we are working on this. So we don't have anything special. We just have a special GitHub repository for this working group, and you just create pull request with your schema changes, and then there is discussion about that. Nothing fancy.
Okay, another one. So at the very beginning, you mentioned that with the original NodeJS GraphQL server, you basically ended up with something like backend for frontend. And
yeah.
This was like GraphQL was sold to me on many occasions that this should be exact solution for that problem. So how did this happen? If you could share some like insight into that.
Good question. I have hard time.
Oh, sorry.
Use the mic.
Oh, okay. Can you hear me now? Also, so at the beginning there was a mention of the Node.js GraphQL server, and basically that somehow it happened to be turned into a backend for frontend, and that nobody was actually taking care of it. Nobody was opening it. So I was asking, how did it come to this? Because from my notably almost my experience with GraphQL, so it's always sold to me as a, hey, GraphQL is going to solve that exact problem. There will be no backend for frontend, at least not explicitly one. So it should be kind of a solution for that. And I was asking, how did it come to that? And there is any.
I think it started when front-end developers decide to have GraphQL layer, right? If it's not coming from the backend. So front-end developers decide that they want this backend service, and they want to just change basically SDL or just queries, fields, and so on. But they don't really care about the behinds, right? They don't care if it's called to REST API, gRPC, or if it's directly taken from database. So I think that was the problem, that it really came from the front-end team, and there was no cooperation with the backend. And especially like from the very beginning, when it was only wrapper of API, of REST API, it was fine because it was generated based on what you do in REST API. So no one was actually touching it. But I think most problems came with the decomposition, and when you like moving parts and you are developing something new. So you need to basically, as a front-end developer, and it comes to that problem as well of ownership. So basically front-end developers were forced to go to this layer and change it for themselves, and then ask the backend developers, okay, can you just change it on your backend so I can call it from this layer? So basically, yeah, multiple factors actually.
Thank you.
Welcome. Mm-hmm.
So you said that you moved the resolvers to the microservices.
Mm-hmm.
What does it actually mean? It means that you moved like the business logic there, and then you, like in the true resolver in the GraphQL, you just map one-to-one the like result set you're getting from there?
Yeah, basically like that, because you have in this layer you have resolver for queries and for each field if you want. And yeah, so what we basically do is to move query by query and move all there shouldn't be any business logic, but it happened in our source code as well that we had some business logic. It should be just basically recalling REST API or gRPC function, right? So it should be just one-liner. So basically you just move this one-liner to your service, and now you don't need to call gRPC because you are in that service that will be called. So you will just get the data from the database and return them directly. So you don't need this layer for recalling stuff, basically.
And what kind of microservices do you use? Is it like something serverless or?
No. We are using Kubernetes with Golang, so yeah, no serverless. Okay, next question.
One more question. What do you use for monitoring of the GraphQL stack?
We have Datadog, so we are sending metrics and tracing from our router to Datadog and to Honeycomb. And the same thing on the layer of microservices. So they are able to send each query in each field if they are interested in. And yeah, with Honeycomb the same. They have just this tracing. So yeah.
So money is not a problem in outreach.
Well, we are moving actually to other solutions. So yeah, Datadog is not the cheapest one. It's true.
And the traces are in Honeycomb, actually. Right?
Yeah, traces are in Honeycomb and metrics in Datadog. Yeah.
Do you have just a single GraphQL gateway, or do you have multiple gateways for each of the frontends? Is it like when you mentioned that there is federation, I'm not sure if you have some like single gateway for everything, or do you have?
Yeah, we have single gateway at the moment. Yeah.
You have single gateway.
Yes.
And my second question, when you mentioned federation, does it work even with subscriptions?
It does not yet, but Apollo is working on that at the moment, and I think it's coming pretty soon. Yeah, but I think it's not a problem with federation. You can like work around it. You can create another server just for your subscriptions, basically. So yeah, you can work around it, but like official support will be there very soon, I guess. But maybe someone from Apollo, they have talk as well, so maybe they can talk about that.
And maybe one more question: when you have microservices and you are communicating between them, there is GraphQL as well, or do you still use gRPC?
No, we are using gRPC. Yeah. Like there were some ideas to use GraphQL inside as well, but we just said that it's not really a good idea. Just use gRPC.